Hi, I'm Dr. Jessica Rutkowski. I'm an assistant professor and a wheat breeder here at the University of Illinois. I'm standing right now in a field of research plots in Champaign-Urbana. And in this video today, I'm going to be explaining how to count spikelets per spike to get an estimate of the average number of spikelets per spike in this field. Now, why might we want to know the number of spikelets per spike? First, it's a component of yield. It can help us to predict our final yield. And yield is a function of the number of spikes we have in a field, the number of grains that are on those spikes, and the weight of those grains. And so by getting an estimate of the number of spikelets per spike, we are capturing one of the major yield components that's going to help us estimate and predict how much yield in terms of bushels per acre we can expect to get in our field. So first, just some basics. Okay, so this is a wheat spike, and on that wheat spike we have spikelets. Each one of these structures that you see on either side as you go up the spike, each one of those is called a spikelet, and inside the spikelets, grains are going to form. On average, each spikelet is going to produce between 2 to 3 grains. There's some variation in there, but research has shown that on average in a field you can expect 2 to 3 grains per spikelet. And that's going to help us to predict how many grains are going to be forming on this spike. Now, at this stage of development, you'll see there's an anther right here. That's indicating that this spike just went through anthesis, or is starting to go through anthesis. And at this point in time, we can't tell how many grains are actually going to be on the spike. So if we actually knew the grain number, that would be even more useful than the number of spikelets. But at this point in time, the best indicator of the number of grains that's going to be formed is the number of spikelets, which we're going to count. I want to point out a couple of things. There are these tiny little spikelets that you can see sometimes at the very bottom, and here at the very top there is one. And usually these do not produce grains, and so we're going to disregard these little tiny ones when we are counting, because if the spikelet doesn't produce a grain, we're not really interested in it. It's not going to help us predict yield. So I'm going to go ahead and show you how you count them, each one at a time. So if you look at this spike, how can I count spikelets? Well, I'll just look as I have the head straight on, or the spike is straight on. I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, and then go down on this side, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's 18. If I want to be a little bit more efficient, I can actually just count one side and count by twos, because if you look at this spike, it's symmetrical. So if I count on one side, I can be pretty sure that there's going to be the same number on the other side. So I can just go like this: 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, so I just counted by twos, going up one side, looking at how many spikelets. As I go up, I count by twos, and then I can get the estimate for the whole spike. So that's just a way to speed things up when you're trying to get a good sample and count spikelets on a large number of spikes. All right, so next I'm going to actually demonstrate how to do this in a field. And the first thing you're going to want to do is find a spot in the field that looks representative. It's not a bad patch, or it's not an exceptionally good patch. It's just a typical or an average part of the field. And then I'm going to go in and grab a sample with my hands. I'll show you just a second. Okay, so I can go in, I would say, okay, this is the sample that I'm going to count. and I'll take that from a row. And there's going to be somebody next to me with a clipboard who's going to write down the numbers that I call out. So I got this bundle here, and I'm going to want to count all the spikes that I've got here. And to help me out, because I want to get a sample of 20, I'm going to just make sure I have 20 in this bundle before I start, so then I know when to stop. Okay, so 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. All right. So I think I got 20 spikes here. And it's very important that you count every spike that you see in that little area, because there's going to be spikes of all different sizes. You know, the main spikes and spikes from tillers. And so you want to make sure that you get all the different sizes represented, so that you're not just looking at the big spikes or the small spikes. You want to look at and get a good range, a good estimate of what's actually in that field. Okay. So now I'm going to go ahead, and I think you can see, right? So I got the first one here. You can kind of see in the camera. And I'm going to count in my head and call out the final number. And I'm counting in my head by twos. Okay. So 2, 4, 6, 8, 10, 12, 14. 14. Okay, and the person with the clipboard is going to write that down. Now I'm going to count this in my head and call out the final number. 16. And notice as I count them, I'm taking them out of this handful. So now my handful is getting smaller each time. 12. 14. 14. 18. 16. 16. 14. 10. 16. 16. 14. 16. 16. 14. 18. 16. 18. 16. 14. 16. 14. All right, so we just counted the number of spikelets per spike on 20 wheat spikes. And the person who would be next to me recording data wrote that all down. And then we're going to take an average of those numbers. And that's going to be the average number of spikelets per spike that we can then use in our yield formula to predict the average yield in this field. All right, thanks for watching.